Hello everyone, welcome to Salesforce Network Lightning Web Components tutorial. Topic what we are going to cover in this session, that is LWC Framework Architecture. This architecture provides a robust, modern and high performant way to build applications on the Salesforce platform. LWC is built on modern web standards such as custom elements, Shadow DOM, and ECMAScript 6 JavaScript. The framework provides reactive data binding, encapsulation with Shadow DOM, and modular JavaScript to build reusable components. Event-driven communication ensures seamless interaction between components. LDS stands for Lightning Data Service. It allows data to access without Apex, while Apex can be used when needed. Locker service ensures security and isolation between components. LWC integrates deeply with Salesforce platform services like Apex, Lightning Data Service, and Lightning Message Service. Web Standards Based Framework. LWC is built on modern web standards such as ECMAScript 6 Plus, Web Components, Shadow DOM, and custom elements. This minimizes the need for custom abstractions or frameworks and allow developers to create components in browser native way. Custom elements. Custom elements are the foundation of web components. They define new HTML tags in a web document and extend the existing set of HTML elements. In LWC, components are custom elements created using JavaScript classes that extend the base Lightning element. Shadow DOM. LWC uses Shadow DOM for encapsulating the DOM structure and styles within a component, ensuring that the component's internal structure and styles don't accidentally affect the rest of the application and vice versa. The Shadow DOM also provides isolation, which increases security and maintainability by allowing scoped styles and scripts. Example: the styling and HTML within a Shadow DOM cannot be accessed or altered from outside the component, ensuring strict encapsulation. Reactivity system. LWC has a reactive system that allows the user interface to automatically update when the underlying data changes. Properties decorated with @track or @API are reactive, meaning any changes to these properties will cause the component to re-render. Templates. HTML templates define the structure and content of the component. Unlike Aura components, LWC templates are based on standard HTML and provide cleaner semantic markup. The styling of components is done using CSS or SLDS, Salesforce Lightning Design System, and it is scoped by the Shadow DOM, meaning styles are encapsulated at the component level. JavaScript. The JavaScript in LWC is written using ECMAScript 6 Plus standards, allowing for features such as classes, modules, promises, and async await functionality. LWC fully supports JavaScript modules, which makes the code more modular and reusable. Component lifecycle. LWC components have lifecycle hooks that allow developers to control the behavior of components during their creation, updating, and removal. These are following: connected callback, called when the component is inserted into the DOM. DOM is for Document Object Model. Disconnected callback, called when the component is removed from the DOM. Rendered callback, called after the component's template is rendered. Lightning Data Service Integration. LWC integrates seamlessly with Lightning Data Service, allowing components to access Salesforce data without the need for Apex code. Lightning Data Service provides methods for fetching, creating, updating, and deleting Salesforce records. The @wire decorator is used to connect the component to Salesforce data. Events in LWC. Communication between components in LWC is done using events. These includes custom events used for component to component communication, like parent child or sibling components. Shadow DOM events, events like click, change, etc. are natively supported by the browser. Parent components can listen to events dispatched by child components and vice versa. Lightning Locker Service. Locker Service is a security architecture built into the Salesforce platform that enforces security and limits the scope of a component's access to other components. LWC uses the locker service to ensure that the components are sandboxed, meaning they can't access each other's JavaScript objects, DOM, or global variables unless explicitly allowed. Apex integration. While LWC leverage standard web technologies, there are times when components need to interact with Salesforce server-side logic via Apex. Using @Aura enabled annotation in Apex classes, methods can be invoked from LWC to perform operations that involves Salesforce data or complex logic. Lightning Message Service. Lightning Message Service (LMS) is used to communicate between different components, both LWC and Aura, across the application. Lightning Message Service allows components that are not related in terms of parent-child to exchange messages without the need for direct communication or hierarchy. Service APIs. LWC also integrates with other Salesforce features like platform events, PubSub, and Chatter APIs, making it possible to build real-time, dynamic, and interactive applications. Thank you.